Good morning, everyone. I'm Josh George. I'm with the network engineering team at Google. You're going to see my colleague, Anish Sheikh from Network Architecture in just a second. So we're going to talk to you guys today about three things. The whole vein of the talk is really around manageability and manageability at scale and how that is sort of being driven by some of the concepts that we're looking at in terms of programmability, APIs, blah, blah, blah. We'll get into more detail, so let's go ahead and just jump right into it. So what's driving this talk? This kind of will be the ground floor for us for some of the motivations. So in our network environment today, some of the challenges that we're dealing with, we have 20 plus network device roles, half a dozen vendors, multiple platforms, multiple generations of those platforms in service. Currently we have around 4 million lines of configuration. Currently trending around 30,000 changes per month into the configuration depots. Every 5 minutes, we collect around 8 million SNMPoids and store them. And around 20,000 CLI commands are issued every 5 minutes across the fleet, and that data is also parsed and stored. Naturally, this lends, we have many tools, multiple generations of software, multiple generations of network software to interact with. So there's a significant challenge here in that, we want to be focused on accessing these devices efficiently, storing this data efficiently, parsing it efficiently, but the divergence in hardware and software that the operator community has to deal with is causing a lot of dilution in the software focus that we have. So continuing on, just to kind of reiterate, OpEx, I think everyone here is probably experiencing this as well. OpEx is becoming a dominating cost factor in network infrastructure today. It is growing. It is growing with every sort of new tool you put online, with every new platform you put online, every new version of software you put online. The OpEx to manage that is going to go up, unless there are some opportunities to sort of curb that. I think that's one of the core motivations for what we're talking to you about today. So just to, again, keep setting the stage, the management plane has some challenges in how we're dealing with these devices today. Some points we'll just throw out there. CLIs that you interact with are proprietary in most cases. That leads to a lot of scripts that are generally written to focus on one CLI or another. Configuration is often imperative, so that you basically have difficulty in telling a device the end state you want it to be in. If you want to move an interface around, you actually have to sequence those steps to the device yourself. You have to tell it, do this, then do that, sort of a workflow that you design on your own, rather than just saying, I want the end state to be X. There's a significant lack of abstractions. I think you guys have seen several talks so far during this conference about sort of better ways to wrap and abstract some of the primitives that exist on their own today. This is actually a big problem for us. I think we mentioned just a minute ago, a lot of data that we collect is not available via things like SNMP, which is an even more difficult problem to deal with, in that we need the data, we have to have it somehow, so we wind up having scripts that go and execute CLI commands, bring that back, we use regexes to parse it, and then determine what data to store after that. And then a little bit of the preview for the next set of discussion is going to be around SNMP. It's not always simple, and we've actually found that the scale challenges of SNMP are growing to be debilitating. So we want to propose a framework that sort of focuses on data on the device. So we're calling it model-driven network management, and there's sort of 3 blocks that we're going to throw out there. We'll talk about 2 in detail today, and the third one we can always have an offline conversation during the conference if you're interested. Those 3 blocks, go ahead and just throw them out there. Topology, configuration, and telemetry. So topology, obviously, sort of self-explanatory. We're not really going to focus on that, but it's valuable to have a way to model the actual connectivity in sort of a graph fashion of your network devices. But what we will focus on in depth today, configuration and telemetry. I'm going to speak mostly about telemetry, and my colleague Anish is going to talk to you guys about configuration. These 2 ideas are what we want to focus on, because we think that there's a lot of value if we can sort of address these in a fashion where We eliminate the divergence between different versions of software, different vendor implementations, so on and so forth. If there's a standard way to read data from a device, the device can represent it in a structured way. And there's also a vendor-independent way for us to send data down to the device. That's sort of the configuration part of that. You guys have probably seen there's a lot of model work going on the IETF. Yang seems to be a very hot topic on these fronts today. But we're actually going to be able to discuss sort of a common modeling language, but then the data encoding is actually something that is going to be fairly flexible, and that can be, you know, at the whim of the operator, so to speak. Telemetry, we're going to hopefully get into this in a little bit more detail, but we're looking to say that telemetry is also something subject to modeling, and that you can actually model the operational data on the device in a structured way. And then you can deliver that back to something that doesn't actually have to go through a very difficult parsing cycle or something custom. It's actually as self-describing as you can make it. So again, we're going to focus mainly on configuration telemetry. Telemetry will be next. And I will say this, if anyone in here really, really loves SNMP, this could be graphic, you may want to leave. We are agnostic, but we want to kind of present as much as we can, sort of an objective picture of some of the challenges we see with SNMP, and then hopefully some of the solutions that we're hoping to get your input as the operator community on. So just fair warning. So telemetry solutions today, obviously, SNMP is the default choice. You turn a device up, 99% of the time, people will be managing it with SNMP. I think you saw Shelley's talk from Cisco yesterday mentioning some of the history of SNMP. It is a relatively old protocol. If you actually go back and read some of the original protocol specs, some of the core design choices were actually made to deal with the very limited processing capability of network elements at the time, and also the limited bandwidth available to those network devices to send data upstream to their telemetry endpoints. It's expensive to discover things with SNMP. You basically put in a new line card, you actually have to rewalk the device in order to figure out, hey, there's a new piece of hardware. So you wind up in a bunch of challenges about either overloading the device with discovery cycles or not even actually knowing when to run the cycle. Maybe you do it every 30 minutes, you may have a blind spot about something new coming online that you want to pick up on. There is no capability advertisement with SNMP. If the MIB says it's there, you often have to test to make sure that the OID is actually supported. And that doesn't lead the protocol to actually telling you what it's capable of providing you from a telemetry standpoint. Rigid structure, I don't know anyone in here, I'll raise my hand, have actually written an SNMP MIB. It is something that isn't really fun to do, and it's sort of archaic. So there's a very limited number of people who are out there extending the data sets that are offered by SNMP. And then often proprietary data, really focusing on the multiple mappings required. Often you poll SNMP, you get a bunch of indices from different tables. It's now on you as the operator to tie these indices together to give you a complete picture of what's going on. Think about QoS stats on an interface. You may have traffic stats, you may have QoS stats. You will have to line those up somehow, and that's extra processing and cognitive overhead that you're responsible for, rather than offloading that to the network element itself. And this one, I realize this sounds a little bit harsh, but it is true that there is a large surface area of open source work going on right now in terms of transports, RPC frameworks, data encoding mechanisms that SNMP just is not taking advantage of. Sort of the telemetry itself out there is not really taking advantage of that. So these are some of the things that we're hoping to kind of address with a new way to look at telemetry. So just some of the challenges, just doing a little bit of reiteration, but with a little bit more numerical data around it. Object collection is growing with each platform generation. I think you guys can see from some of the demos at Beer and Gear, the actual platform density is growing significantly from the vendor community. 100,000 objects on current platforms. Our projections are that grows 3 times over the next 2 generations. And those are conservative numbers without factoring in any new software features or things that may require monitoring as well. Object collection frequency is also important to talk about, and we'll actually speak about this in the bullet coming just in a second. But the trend is continuing. There's no real surprise there. but there are scale limitations at the data acquisition at a high frequency. So if you have an extremely large device, you want to get data off very, very frequently, it's a challenge. We have not been successfully able to do that with the newest platforms that we're deploying in our infrastructure. And it's proven to be, a lack of visibility is a lack of data to operations, which is, a serious blind spot that can cause us problems. But the crux of this is the need to acquire this data is being driven by a lot of these talks that you guys have heard. Whatever buzzword you want to throw in here, SDN, NFV, blah, blah, blah. It is basically that these technologies all depend on operational data to be able to arrive at an optimal solution. So garbage in, garbage out. If you want tight control loops, if you want software systems that are steering traffic on your network, you want to be able to feed those systems with the most accurate data and the most fresh data that you can possibly give it. So this is putting another sort of impetus on telemetry to grow, in addition to just the native growth of the platform over time. So this is just kind of reiterating what we're talking about. So again, we don't really like SNMP, that's true. But in terms of having a constructive dialogue, there is something that we're wanting to propose, mainly to everyone here, the operator community, to try to get some specific feedback on, and more importantly, to try to get your involvement in, because this is something that is still coming together that we'd like to get as many people that sort of sit in the chair, that feel the pain, that actually have a need for this as possible. So what are we thinking? So again, you probably saw a preview yesterday, but reversing the flow of telemetry, where instead of going out and polling the device, going out and saying, give me these things that I think you have, kind of reversing that flow and putting the onus on the actual network element to stream that data upstream to you based on a subscription and a sort of publish-subscribe model. So also, observing network state through a time series data stream is something that you can actually construct an offline model of your network in such a way that if you're getting data frequently enough, that model can be used to sort of have, think of it as a network rsync. Like you can rsync your network over to an offline system if you have fresh enough data, play with it there, and actually kind of observe how the network is reacting in sort of an offline fashion. So Anis is actually going to get far more in detail to the data model, but a data model is actually really important here in that if the model exists on the device in a standard way, and as many of the things are represented in terms of a Yang model or whatever the flavor du jour is, that allows a lot of flexibility in sending structured data upstream to you in ways that you don't have to do really creative ways of parsing. You can have it be self-describing. And then a really important part is also in the use of sort of transport and encoding protocols that exist today that are secure and that are focused on efficiency and that are not necessarily 20-year-old protocols that haven't really been kept up to date. So going into, oops, clicker. So just some of the requirements that we're putting forward on our end, and this is again something we'd like to collaborate with you guys on specifically. A push model upstream, devices will stream their data to a network collector. That data is actually populated on the device in a data model that is vendor neutral whenever possible. So an interface traffic stat counter on a Juniper device is an interface traffic stat counter on a Cisco device, Arista, so on and so forth, whenever possible to be standard. And then when that has to deviate, Anis is going to talk in more detail about how the models can actually deviate and be augmented to have vendor-specific knobs and features in them. A publish-subscribe model using an API where you actually tell the device what you're interested in, at what frequency you'd like to have it and where it should send it, set it and forget it. At that point, the device is now given its, its marching orders, and it will send that data upstream to you based on what you've told it to do. We're looking to make sure that we have something that can scale organically with platform growth as well as have very high data freshness. High data freshness to us is somewhere in the neighborhood of 1 to 10 seconds for every individual sensor or counter on the device. And actually in this discussion, I think we're seeing that other protocols are doing load management by actually distributing functions to hardware. Telemetry is another option for that to happen as well. And that's one of the things we're encouraging people to look at is how can you actually move the telemetry load out into the device as far as possible to make sure that the load is maintained without being on a central point of failure and or congestion. Again, using modern transport mechanisms with a development community that's active, people are actually putting pull requests out on GitHub, they're developing, it is something that people coming out of college will actually be able to make use of. It is not an archaic protocol that you have to find specially trained people to deal with. There are some examples here. We actually have just open sourced an RPC framework called gRPC. If you're interested, I would encourage everyone to take a look at it. It's available at grpc.io, and there are some backup slides that have more detail in it in this deck. Thrift has been around for a little bit. It's also something to take a look at. Or if you wanted to take a very simple approach, just transporting protocol buffers over UDP, fire and forget, as long as you have a way to detect data loss, is another option. So just to kind of, translate this into the way we're thinking about how we would configure this kind of system, there are a couple of steps to the process. So in this case, a network element is actually going to come online and actually advertise a capability set of, hey, I have these sensors on my platform, I have these capabilities, and I have this inventory. Something important, if you don't have SNMP, you still have to have a way for the device to describe its inventory. So the device comes online, it actually pushes this upstream to your network management system. The red endpoints here are gRPC endpoints or whatever RPC API framework you guys would like. But once these inventory capabilities are sent upstream, you will have rules which you can define. I'm interested in interface statistics on Ethernet interfaces every 2 seconds, and whatever your operations staff may want to have for an override. I'm debugging something. Let me put that in as well. Network management system will coalesce this together. It'll generate a monitoring configuration, and then publish that to the network element. And at that point, the network element is now configured with the monitoring. It needs to send. It knows where to send it, how frequently, and you're off and running. The flip side of that is the data flow off the device to your collection system. You can send statistics every X number of seconds to your collector, whatever it may be. It can be a workstation running under someone's desk. It can be an actual, large cloud-based service. You also want to be able to asynchronously report events. LSP has gone up or down, interface has gone up or down. Those are also very important in the concept of like SNMP traps. You don't want to overlook that data. And then also, this is an important part, is sort of operator requests for ad hoc data. This is someone logging into the device, issuing a show command. Hey, show me all the blah, blah, blah on the device. If you're doing this via a telemetry channel in a structured way, your CLIs can actually become much more powerful. Your CLIs can actually understand semantically what the data is coming back to you. It can actually flag things that are important. Think about a large show interfaces output that actually highlights error counters or highlights other things that may be of interest to people. As long as you're doing this in a structured way with a model that is as vendor independent as possible, that sort of automation is relatively easy to do. But just to recap, the 3 types of data that we're attempting to cover in this system are bulk data, which is raw time series data, blasted away, event-driven things, and then sort of the operator request and response, which we already covered. So practical realization, this is where I'm wrapping up, and just trying to say this isn't necessarily a pipe dream. This isn't something that is intangible. In that you saw a talk yesterday from a vendor on a streaming telemetry discussion. You're going to see one, I think, after our talk here. These things are actually being developed right now. But it's not a final product. We're experimenting. We're trying to find a system that actually is usable, but it is completely for naught if it is not a larger discussion in the operator community. So this is mainly a call to action for you guys. If your monitoring is fine, then that's cool. Everyone's happy. However, if you are concerned about your monitoring over time, or you want to make your monitoring better, or you just want to explore these ideas, now is the time. Now is the time to get involved, to try to get your input into these systems before they sort of close down, because the systems really are geared to make your lives easier in the operator community. So there are vendor implementations available now for experimentation. This is where I say you can see who gave these talks at this presentation. Go talk to them, go talk to your account teams, and just let them know you're interested, and you can kind of see where things are in the community. So anyway, that's just sort of reiterating, now is the time to get involved. If you're interested, Anis and I are here for the rest of the conference. There's an OpenConfig website in the deck that has contact information for us. If you'd like to sort of reach out, we'd love to continue the discussion with you. And at that point, I'm going to hand over to Anis, who's going to talk about the config side of the puzzle.
Thanks, Josh. Okay, so OpenConfig, we don't have a lot of time left, but in the short time we have, I wanted to essentially give an overview of what the working group is. So OpenConfig is a collaboration, an informal one, an industry collaboration among network operators. And it's motivated primarily by all the challenges you saw Josh describe at the beginning, the lack of abstractions, the lack of programmability that results in the lack of APIs to the network, the fact that we have so many different tools that have to manage the heterogeneity and complexity of having multiple platforms, multiple generations. Every time we qualify a new platform, we have to qualify all of the tools that talk to that new platform or the new generation of that platform. So there's a series of challenges that arise from a lack of a common way to access configuration on network devices. So this is just the executive summary of what OpenConfig is. As I mentioned, it's a collaboration among operators. So it's informal in the sense that all the operators involved haven't signed a single piece of paper. There were no lawyers used in the effort of putting this thing together. It's just a bunch of network engineers from different operators who share the same needs and vision and goals, working together to get some work done. You might also wonder why this is a collaboration. Why didn't Google just proceed on its own? It's really to get the force multiplying effect. So it turns out that there's a large number of operators who we've spoken to that share similar sets of goals and challenges. And when we approach our vendors to actually implement support for some of the models that we're talking about, it makes a big difference when it's more than just one customer coming to them, right? So the idea here is to consolidate the requirements across a set of customers, hopefully a set of important customers to the key vendors that we care about, and then approach them that way. Our focus, as Josh mentioned, is on taking this model-driven approach. So one of the first things that we're doing is developing these vendor-neutral data models for both modeling configuration on network devices as well as operational state, and I'll say a bit more about both of those things. The key distinction between what we're doing and what I think the rest of the community has been doing around data modeling is that we're taking a pretty purist view as far as reflecting real operations and real usage. So by involving operators in defining the models, we ensure that the models don't degenerate into sort of lowest common denominator, and they also don't try to represent every last feature on the devices, right? So we're not trying to be exhaustive. We're trying to focus the models on what is operationally useful and important and what people actually use in their networks. We have adopted Yang as the data modeling language. There's a lot of momentum around Yang. Vendors are supporting Yang-based stacks on their devices. If you're not familiar with Yang, it's an IETF defined data modeling language standard. It's in RFC 6020. So who's involved? When we started this, we essentially approached AT&T and asked them if they would be interested. We had had some other discussions with them. They were interested, and through the IETF, we got connected with a couple of other operators, and it sort of grew and grew after that. So we're up to essentially a list of 10 or 11 operators. You can see them here. All, if not most of them, are quite active in the group. We have a meeting every week, and we do our work offline, and we essentially use GitHub as the repository for the output of our work. So the main output today is primarily model code, which we publish in via open source in a public GitHub repo that periodically gets refreshed, and the link is there in the slides. You might ask what this has to do with other efforts in modeling, whether it's in IETF or in the ONF or in open source projects like Open Daylight or ONOS from ON Labs. We do interact with all of those organizations in addition to our vendors, of course, which is our primary interaction. But we do publish our models as well as other design documents in the IETF just to inject the operator perspective into those communities. So just to make this a little bit more concrete, where do these vendor-neutral models fit into the configuration pipeline? So we start with this notion of having a relatively high-level abstract intent API, right? An operator might want to drain a peering link, for example. That usually translates into some change in topology. So there's maybe a link that needs to be taken down in order to effect that intent. The result of that topology change then results in a set of configuration changes, right? So the configuration changes have to be generated based on that update to the topology. Now here is where in the current set of tools that we have, you have this big branch, right? If it's a Juniper device, I've got to issue this set of commands. If it's an Arista device, I've got to issue that set of commands. Or I've got to get that vendor-specific template, or issue this particular API call. So that's the stuff that we want to do away with. I mean, the onus has been on the operators thus far. We're trying to push that further down to the devices. So here's where the vendor-neutral models come in. The configuration data that gets produced at this step is actually vendor neutral. So you produce configuration data that will work against any device that supports the models and that can be validated. So Yang itself has some constructs in it that allows some basic syntactic validation, checking for ranges, defaults, pattern matches, things like that, simple things. And then of course you'd have some business logic that would do your own validation and checking of the config. And then you can push it down to devices directly. So there's no translation to a vendor-specific language or configuration style. You essentially push it to devices that support it. And here is where we're working with some key vendors to actually support the models directly and natively. So each of the vendors' devices will have to do some sort of translation to their native schema, issue those configuration commands. And of course, when you read back configuration, either through the telemetry channel, as Josh discussed, or through some show command, you want to see the data also in the same schema that you sent it down in, right? So you don't get the data back in the native schema. So this is sort of the end-to-end flow that we're envisioning, and we're building a stack now at Google and testing it that actually follows these steps pretty closely, using some of the Yang models that have come out of OpenConfig so far. So one of the first questions that comes up when we talk about this is that, well, this base vendor-neutral model sounds great, but what about devices that don't quite support it or need to support some additional things? So it turns out that there is a relatively natural way to do this. This is one of the key features of Yang that we actually appreciate it for. It has a lot of other rough edges, I'll admit. So the idea is that you have this base model. Again, it's not a least common denominator model. It's an operationally useful, comprehensive model that reflects all the use cases of the operators that were involved in developing it. But then there's also an opportunity to extend the model. So for example, vendors might propose modifications that add specific configuration nodes for some feature that they support uniquely, right? That isn't supported on other devices or platforms. They may also not support the entirety of the base model, so there might be a deviation from the model that they issue. The nice thing in Yang is that you can create these augmentations and deviations programmatically, right? So they're just another Yang module that, when overlaid with the base module, gives you a resulting model that represents what's actually supported on the device. Now we're pushing our vendors to support the base model in its entirety, but in the near term, it's obviously going to be the case that not every bit of the model can be fully supported. So we fully expect to deal with deviations and augmentations, at least for some time. And then, of course, there are other modifications that might be local to an operator's usage. So an operator might have specific data that only they need to consume. You can similarly extend the model with those data nodes so that your management stack can understand and use them. So where are we in OpenConfig? We've been working at this for probably close to a year now, maybe just a month shy from when we officially sort of kicked this off. In that time, we've produced some fairly complex data models. So we spent actually a number of months focusing initially on BGP and routing policy. So we've published a pretty comprehensive BGP model, also a generic routing policy model that also supports BGP specifics. There's details about both of the models on our website and also in the IETF drafts we've published. The good news is that there's actually multiple vendors who are now starting to support the model. So we've had demos in labs across the OpenConfig operators that actually support the consumption of these models directly on those devices. We've also done a fair bit of work on an MPLS and traffic engineering model, and this is sort of a consolidated model. Again, the approach is really operation-centric. It's really, the model is not protocol-centric. Is it RSVP? Is it LDP? Is it SR? It is really about, okay, what kind of LSP am I trying to create? What are the different items that I need to configure? Some of them are protocol-specific, but we're trying to create a framework that's natural for operators to use. And I think that can only arise when you have operators involved in defining the models. So our initial focus of this model has been on the RSVP TE portions and also the segment routing portions. And again, those models are published in the public repo that we have. We've also, in addition to the models themselves, tried to move the conversation forward in the Yang and NetConf and NetMod communities by offering up design patterns for how you should model things like operational state, which has been relatively sort of unaddressed in the current work that's gone on. And also the need for actually putting models together. I'll say a little bit more about that in one more minute. And the other thing that's come out of OpenConfig are now some tools for translating Yang models into actually usable code artifacts that you can use in your management systems. So I'll just mention one of them. This is Piangbind from Rob Shakir at BT, who's an active member in OpenConfig. This will create Python classes for an OpenConfig Yang model that then you can use to populate with real config data. And then we have a number of other models in progress. I'll just mention a couple. We're revisiting the interfaces and systems model to make them more comprehensive and useful operationally. We've also just started talking about a draft of an optical transport model, and there'll be more models coming. So I'll just mention two more points before wrapping up. One is that a lot of the work that's gone on in this modeling space has been very focused on defining a model. Right? The problem with that is that I can't set up a service or even a device with n interfaces model or a BGP model. I need a set of models that work together in a coherent fashion. So model composition to create an overall device model or an overall network model is crucial, but it's really been a missing piece of the modeling work that's gone on. We've actually proposed a way to compose models, at least at the device level, how the different individual models should be fit together to create something that's more comprehensive and useful. The second is about modeling operational state. Yang has thus far been really focused on modeling configuration, but we're really trying to explore how to use it also for modeling operational state. This includes the state that's reflected by sort of derived or negotiated values. Think of like a negotiated BGP hold time, the state that you might normally think of as counters or statistics, and also state that represents the intended configuration. So oftentimes you have systems where the configuration that you push down is not necessarily the actual configuration right away. There's some time that it takes for that configuration to be actually committed. So by treating configuration as state, you can actually see this mismatch directly and also get a sense of how long it takes for that config to propagate. So we see clear benefits in using Yang for modeling both styles of data. And there's a bunch of conventions and design patterns that we've proposed and we're discussing with the IETF NetMod community. So finally, just to wrap up, Josh opened the talk by mentioning that a lot of the work that's gone on is been related to control of the network, right? We're applying all these new paradigms and techniques to the control space, but relatively little attention still being paid to the management space, right? So really we're looking for a way to make the management plane more programmable, more API driven, handling abstractions, all the things that we mentioned through the talk. So there's three core principles that I think we're sort of pushing here. One is this idea of model driven management that we talked about earlier. The second is really changing the way telemetry and monitoring is done to more of a streaming style that really improves the scale and also the freshness and accuracy of the data. The third is really pushing for a vendor neutral way to configure APIs. We don't buy different platforms because they have different CLIs. We have considerations whether it's density, robustness, price, whatever it is, but the fact that I have to use a completely different CLI to configure BGP on every different device just doesn't make any sense, and there's no real reason for it that we can see. So this is a core principle that we're driving. So two examples of this, the architecture and the reference to emerging vendor implementations of the multi-mode streaming telemetry type solutions. You've seen examples yesterday, you'll see another one today shortly. And then also we've talked about OpenConfig, which is a collaborative effort by network operators to develop these vendor-neutral models for APIs to the management plane. And then finally, the last thing is, we just urge other operators to get involved. If you share these goals and this vision, get involved in OpenConfig, be an active participant either in sharing your requirements so that the models reflect the things that you need, and also pushing your own vendors to support both the vendor-neutral models as well as the telemetry solutions that were outlined before. So this is happening now in the industry. We have multiple vendors, as I mentioned, involved in these implementations, and we'd really like to get more operators involved in providing the input. Thank you very much.
Hi, quick question. Why why isn't the industry embracing what's happened with server management? You know, Puppet, Chef, these other tools that we're using to manage our other devices. Why don't we just integrate the same? Why don't we use JSON, all these message queuing buses, things that are well established? I don't know about well established. Maybe I'm from San Francisco. I've been doing too many web startups, but these are the same problem sets in my mind. Different devices. Why don't we use the same technology?
So, you know, I think some of the technologies you mentioned are certainly potentially viable. You know, I think our own view on this is that the tools that we use for server management, yes, they've been applied for things like white box data center switches. I'm not convinced that they apply across the board to much more complex pieces of networking gear that are, you know, have very specific network functionality. But that said, it is feasible, although, you know, just because I have a JSON-based encoding doesn't mean I have a data schema, right? The models are still key. So having a model that represents the actual schema in a vendor-neutral way could still be used with a Puppet-style configuration system, or use JSON encoding, right? So we're really focused on the models and less so on the transport and the data encoding. We consider those sort of secondary.
Hi.
Hi, Ed.
Hi, Josh. I'm Ed. I work for Amazon. I guess I have a quick question, which is basically, why push this in this way, right? There's a number of different repositories at this point for various Yang configuration modules. There's all the Open Daylight stuff, which is primarily Yang-based. There's I2RS and IETF. And I guess you guys are positing that this is fundamentally different in some way. From a technological perspective, it's not clear to me why we need all of these separate efforts. So I guess I'm wondering, just specifically, what's different about this than the 2 or 3 others that are going on right now?
Again, I don't know that I would say they're fundamentally different, because at the end of the day, they're all producing Yang models. And in fact, we're publishing the models in some of the same repositories that you mentioned. And as far as the working groups, whether, as I said, we interact closely with IETF, and we're trying to leverage the work that's going on there. But I think what is unique about this is that it really is an operator-driven perspective. It is the consumer's view of what the data models ought to look like, as opposed to the back-end view, which is currently how most of the models are being defined, meaning that, you know, vendor-driven models tend to reflect implementations, and I think just the perspective on the models has been different.
Are you positing that IETF is not an effective forum for large network providers to drive these sorts of models?
Well, I think that IETF has its challenges. I wouldn't go so far as saying that it's completely ineffective. I mean, if you saw the presentation at the last NANOG from Chris Grundeman, I think he points out some of the issues that operators have in IETF. I don't get into that here, but we are trying hard to work with IETF. It hasn't been easy, I will say, though.
LJ Walker, Barefoot. I'm sure it's been considered, but it's not obvious how. If you go back to that slide where you had the 2 trees, the base model, the extended model, you don't have to actually put it there. But I had horrible flashbacks of all the vendor-specific OID, MIB kind of catastrophe, and in a former life being somewhat responsible for that expansion. I'm interested in how kind of organizationally you're going to keep people from doing the same thing and screwing us all again.
So, LJ, it's a great point, and it is definitely a risk in this approach, right? I think one advantage we have here is that we have a multitude of operators all asking for the same thing. We're pushing our vendors to not support their own version of the model. There's a base model that we're expecting and pushing all of them to support. We're just recognizing the reality that, at least in the near term, there will be deviations from the model. And vendors should be free to add their own specific special knobs, because they have customers that may depend on them. Now, the point here, though, is that you can do this extension a bit more programmatically than we could do in the past. The hope is that that will make it a bit easier to deal with. But I fully agree that there is a risk of that happening.
I guess my only follow-up would be, when dealing with vendors, you would probably be well served to be more rather than less strict in how you present that. Because otherwise, I think if you give them an inch, they will take a country mile. So, thanks.
Yeah, fully agree. I think we are being as strict as we can. That's why we have people like Igor helping us, for example.
And LJ, just to kind of reiterate on that point, like the base model itself is trying to be as complete as it possibly can. So this is kind of flipping that sort of dynamic around where it's on the vendor to come up with everything, where it's actually on the operator community to come up with the 80% solution. And then if there are things that need to be tacked onto that or modified, then there's a framework to do that. It's possible. It's not necessarily the default choice.
On the same note, Ed Crab, Amazon.
Igor was next.
Igor was next.
Oh,
Sorry.
that's cool.
No, Igor, go. It's fine.
Well, to answer Ed's question in a not as polite way, because I think Anis was trying to be nice, IETF is a pain in the ass to work with. They move very slow. Sorry.
I've heard that.
Yes. You should remember that as being a working group chair. The other major thing is the way IETF is structured into very different hierarchies. One of the things that was very interesting for me about OpenConfig is that it kind of creates one guidance for every different hierarchy of how we want things structured. So we don't have MPLS that's looking one way, BGP that looks completely different, because one is routing, one is transport area, and they don't talk to each other very much in IETF. So this is kind of top level guidance of make everything look the same, because guess what, you're all a router. And that's one of the huge advantages of OpenConfig. And oh, by the way, all of this is being fed back into IETF.
Sort of. Via a set of informational drafts. Yeah.
Well, which is a way to feed back.
Sure,
and then,
sure.
You know,
But I guess the question was mostly around just like why not do this in ITORS? And I guess the answer is you think it's moving too slowly, which I think it is too.
yeah. I mean, all of it is being fed back via informational drafts, which at some point, if IETF wants to pick it up, will become standards. And if we, the operators, tell vendors that this informational draft we require implementation of, then, that's how we get it done.
We have had some luck, by the way, with pushing some from informational to standard. The BGP model, for example, looks like it's making progress in the IDR working group that way.
Oh, that's good. Okay. Thanks a lot, Josh and Anis. Gotta close the mics.